Welcome to the presentation of Group 2. We will assemble a part of the engine, and it's Tom speaking, and later you will hear more from Walter and Matthias. Here in the background you can see the whole assembly of the engine. If you want more information about this, check the last video. We will just focus on 3 parts today. At first, the 8 pushrods. They are assembled with a 3-finger gripper, which is placed in the tool changing position 1. Then the rocker shaft, which is placed by a 2-finger gripper, placed in a special tool changer. And last but not least, we will screw the head cover. And now we will go through this step by step. So let's start with the pushrods. Here in the background you can see that we changed the design of the feeder a little bit. We made it higher because now the new tool changer for the rocker shaft is placed in front of the feeder. But the benefits are still the same. The pushrods are always in the same position, so theoretically speaking we could add hundreds pushrods there, and in addition you cannot place them in the wrong direction. And now here in the background you can see our 3-finger gripper. It's a very robust design, and we had no big issues in the designing of the assembly. We just had to take care that we drop the pushrods in a correct way. So the pushrods are already in the engine, and then we drop them, and then there are no problems. And the reason why we had to drop them is the frame. And now you can see the dropping in 3, 2, 1. But let's go to our biggest challenge.
Hi, my name is Walter, and I'm gonna tell you about the rocket shaft related designs. After the midterm seminar, we made some small changes to the fingers of this gripper. The main functionality is still staying the same. We also adjusted the location features a bit. The main design stayed the same, but we had to adjust the level we are locating the rockers to. We also added some material that we can ensure that the locators won't deflect when they are attached to the table. As a third main change, we decided to abandon the idea that we use 2 separate pieces of metal as the frame of our gripper, and instead we opted for a design where we have just one long piece which is attached between the tool changer and the actual gripper. The assembly of the rocker shaft was quite challenging. In the physical environment, we faced the fact that our gripper couldn't fit in the tool changing system that was designed by the core staff. Because of that, we needed an external tool changing point where our gripper could fit. The tolerances for the assembly process are quite tight, and because the rocker shaft has 4 holes where the bolts need to be aligned in quite tightly. One thing that makes that a bit easier is that separate rockers are spring loaded, so in the sideways the tolerance is quite forgiving. During the testing of the assembly process, we also noticed that the aluminium extrusion deflects quite a bit when assembling the rocker shaft. Because of that, we added some extra spaces to the outer locating features to compensate for the deflection of the shaft. This might not be the most elegant solution. With this small change, the assembly process works as intended.
We also had a screwing task for the head cover. There 3 M10 x 90 bolts are screwed so the head cover stays in place. For the screwing tasks we designed a holder for the screwdriver, and the holder is designed in a way that it doesn't flex much since the screwdriver is located close to the mounting plate. For the bolts we designed the feeder in the table. That's also 3D printed, and since we only have 3 bolts, each bolt has a own slot, and the screwdriver will pick those from the slots. For the screwing, the screw is first picked up from the bolt feeder and then placed to the cover. We ran into problems since the screwdriver controller was broken and we can't use it. So the first problem in the picking the bolt is that we have to know the orientation since we can't rotate the screwdriver, and this is done to avoid collisions. When placing the screw, we have to remove it because we can't rotate it, and this is done via flex pendant note for the user. And after that all the movements are the same. The screwing speed is 5 millimeters per second, and it's based on 1.5 millimeter bits on the thread and 200 RPM speed from the screwdriver. And this screwing process continues 3 times for each bolt, and when placing the bolt, the targets are offsetted.
Finally, a few learnings. At first, the robust design. For example, our 3-finger gripper is very robust, and the good thing is now we had no problem with some broken parts at all, and it's just good to make it a little bit more robust because then you don't have to worry about this. The next 2 learnings are closely connected. At first, we learned that it's very good that our rocker shaft stuff was easy to adjustable in the end. So we could just add a washer here, and then everything works. And this was because the whole rocker shaft was so complicated that we couldn't do a 100% accurate 3D model, because this is now to the next point, the balance between virtual and real. We could have spent 2-3 days with 3D model and it wouldn't be perfect. So there we had a kind of simple model, but it was good enough for this. But for example, on the other hand, we could have done a little more in virtual components. So we had to adjust some movements of the robotic later directly with the robotic. So there, I think this is a nice learning from this course, that we all have to find the perfect balance about what can we do and prepare on the software and what do we have to do in the end with the robotic itself.